right. Thank you so much, colleagues. And I'm definitely... No. Oh, shame. Thank you. I appreciate it. I appreciate it. Being from, I think that was a pity applause. But be that as it may, I certainly, after Kanyisa, I had to drink water. She was like, broom, going through a presentation. At such a rapid pace. So I will only skip through what I believe the important slides are in the interest of time. So I won't go through your basics around, I think everybody here knows what industrial symbiosis is. Eskom itself has had a long-standing integrated waste management system and standard, and this sees us really reporting on a number of our waste streams on a monthly basis. Only the hazardous ones, the top ones, are actually reported in our integrated annual report. But I'll give you a little bit of an introduction of the different types of waste streams that we have, and then also look at the most prominent ones where the industrial symbiosis opportunities lie. So when we look at IS, it's not just a comprehensive approach. There's different subsets of industrial symbiosis, and it's not only involving cross or external companies with yourself. It's also your own processes inside your own operations that you can actually look at making more efficient. Case in point being the reuse of heat. In other areas of particularly your generating plant, your coal-fired generating plant. But I'll get into that. Then there's also your water-based IS. Eskom certainly in its normal baseload operations of its normal coal-fired power plant uses a tremendous amount of water. There has been considerable efforts to try and turn that down or reduce the amount of raw water usage. And this has come down incrementally over the last few years. There's various reasons for that, but I won't get into that too much. Then the material-based is what I've seen many of the colleagues talk about, is what kind of your byproducts or your waste material can be a feed into another industrial process or for another company or yourself. So in that instance, I kind of feel like I'm trash talking in terms of waste, but I don't intend doing that. And then there's a fourth leg, which also speaks to when we look at industrial symbiosis, it also extends to services where we can operate more efficiently rather than compete with each other, where you have resources sitting idly. Let's work together and look at where we can share those resources, whether it's in evaluation or monitoring of systems, etc., whether it's in creating platforms, moving towards the digital economy. But the one that I want to hone in, or the two that I want to hone in on, is your materials base or your waste IS, and then also your energy IS. And there's three subsets into energy IS, and that is your energy cascading, fuel replacement, where you are looking at a fuel that is quite produces quite a number of gaseous emissions, toxic gaseous emissions, as well as ash, and look at what do we use to substitute our input or our primary energy inputs to have a more sustainable and less harmful impact on the environment. And then also bioenergy production. Quickly, in terms of the waste streams that we monitor on a monthly basis, there are a few more, but they were to a lesser extent. Certainly a few we venture more towards the general side in terms of reuse or recycle. Much of the hazardous waste in terms of liquid and solid hazardous waste at this point, unfortunately is landfilled. We're trying to look at mechanisms to move away from either the use or the production of those hazardous materials. and look at which of them we can actually, under very strict conditions, look at recycling. For instance, a spent battery recycling facility. What would be the benefit for that? Maybe not now, but in the very near future, as your lithium-ion battery, lead-acid battery takes off in terms of distributed generation. We also look at the recycling and reuse of one of our other big waste streams, which is the used mineral oil that we use in our power transformers and our distribution transformers. You can only recycle, regenerate, filter out, impurities so many times before you actually have to dispose or recycle that particular waste. Okay. Then, in terms of quantifying what we have that we can trade or sell or leverage off with other industries, and this is based on last year's volumes that we've produced. Our ash, we have several contracts with the construction industry in terms of the uptake of our ash produced at our power stations. Of the 30.81 megatons, we've sold, recycled, so they're either used in tarring of roads, they're used for building materials, etc. We've managed to repurpose or use that ash in other areas of the economy. Our waste oil, the ones that do not have any more insulating properties linked to them, is then blended, recycled into burner fuel. It's not a renewable endpoint, but it is not being landfilled. I mean, it is burning into the atmosphere, but yeah, it's not ideal for a reuse, but it is not being landfilled. One that I believe we all need to watch is e-waste. Particularly in the cell phone sector. It might not be in terms of Eskom or any of your big corporations, unless it's a tech corporation, where our laptops we have to keep for 20 years. So I think this was a typewriter when they gave it to me. So the amount of e-waste that we use is due to increase as we move towards a digital future. And I also think that is where the future recycling gems are in terms of the precious metals out of e-waste. Scrap metal, just an interesting fact, there is in the mining and metals industry, there is some concern regarding the need for raw materials and the need for new materials. Scrap metal currently makes up about 40% of all metal sales across the world. And the one that, and I do apologize for the next one, which is gypsum, which is produced particularly as a byproduct from our flue gas desulfurization, where we extract your sulfur out of your flue gas, mix it with calcium carbonate, we then produce gypsum. I'm simplifying it a lot, but the intent is the uptake of that gypsum from Kusile Power Station. Should all 6 units be running, and my zeros let me down there, it is not 90 megatons, it is 0.9 megatons. So I will fix it up on the slide, and that is just from Kusile. We haven't finalized the contract yet, but this is an ideal example of perhaps a public-private partnership where we are offering a 20-year agreement with a company through a tender process to set up gypsum extraction. So we're not going to extract it. We are going to allow them to set up an operation that will extract it. Under certain circumstances, some of that value needs to be retained. I think between 25 and 30% of it must remain in the Mpumalanga area. The rest can be, used as a commodity. Typically in the agricultural space, in terms of agricultural activity, as well as in the construction, making wall boards, etc. Demolition materials, this is due to increase as we move through our decommissioning process, or our plant decommissioning process. We are decommissioning systematically 10 power stations, fully decommissioned and repurposed by the end of 2035. By the end of 2030, we will have 9 coal-fired plants decommissioned. One of the key objectives is to look at what else can we do to not leave the communities and the area of Mpumalanga disempowered. All right. Then a few of the others, you're more than welcome to ask me about that. The synchronous condenser operation, with the advent and the input of variable renewable energies into the grid, we do need to compensate for reactive power, because that impacts, because as we decommission our rotating or synchronous generators, it does have an inertia impact on the grid, and we need to then feed more reactive power into the grid. So we are not disposing of our gen sets, we are actually converting them, and in that way creating, revitalizing the use of them to create reactive power. Thermal efficiency starts at home. So we have systematically, even though it's not a phenomenal reduction, but we have reduced through station thermal efficiency baseline assessments, as well as periodic assessments, to look at where those waste energy losses are and whether we can prevent those losses, because the less heat losses you have, the more efficient your system, the less coal you have to burn, the less CO2 you are creating. I've just given a rule of thumb calculation there. 1 kilogram of coal creates 1 kilowatt hour of electricity. Are you scratching your head? Okay, and about 0.9 kilograms of CO2. What we are doing here, even if this is my last slide, I'll be happy. What we are doing here, what you will see is Eskom's engineers have developed a used containerized microgrid. This is a 25 kilowatt peak microgrid housed on a very used container. It's bashed and rusted and whatever by the time when we get it. By the time it gets to us, we revitalize it, we spray it, and we affix PV panels to it. And on the inside, you'll see there's inverters, batteries, lithium-ion batteries, and the control and instrumentation of these units are actually built in-house by our engineers. We have set up a assembly fabrication plant at at Komati Power Station, which is being decommissioned, and that is, we're hoping to bring economic activity to the areas. There's a lot of resources we need. There's a lot of value chain strengthening that is required, and these shipping containers are earmarked for the 13% unelectrified households. Still left in the country. So it will be a lot cheaper than actually excavating transmission network, etc. These are modular. You tow them and you put them down, and they can provide 30 homes, between 25 and 30 homes with electricity. Okay, so that is how we are. So this is what we want. E-waste. EV batteries, once an EV battery gets to the end of its life, it still has about 80% of its life left, ideal as backup in PV or microgrids. So that is where Eskom is going in terms of saying, well, how do we reach more people? How do we electrify more people in a sustainable manner without it costing us an arm and a leg? We've sold the arm and a leg already. So alien vegetation as well. How do we create value out of that? You are more than welcome to go through the rest of the presentation, which basically looks at the opportunities that we have. I will stop here. Did you stop my presentation?
No, it's not me.
Oh, someone interfered here. Someone's remotely monitoring. So this is just basically saying what our carbon CO2 footprint looks like. We all know what our national determined contributions were that we've amended recently. I think September last year, the biggest contributor to CO2 emissions, which links to how much excavation, how much mining we do, is the electricity sector. With our plans of decommissioning plants, we are confident that we can make a significant change and contribution towards meeting our national determined contributions. I will stop there, if that is fine. I'm sure I've been 15 minutes, but okay, but I think I've got the gist of my presentation.
Thanks a lot. Can we give her a round of applause?